This lesson is going to build on information that you already know, which is the interior angles of a triangle, and then add some new information that you don't know, which is to be able to use the exterior angle and the remote interior angles to find out information about the angles of a triangle. So the triangle sum theorem about the interior angles of a triangle, and by interior I mean the angles that are inside the triangles. So those three angles are interior angles. The interior angles of a triangle add up to 180 degrees. So A and B and C equal 180 degrees. If you can imagine that this was a piece of paper and you tore off those green corners and you put them in a line like this where you put all your vertices there, they would form this straight angle, which is 180 degrees, which is why the angles of a triangle add up to 180 degrees. So let's use this fact to find the measure of each numbered angle. So if I want to find angle 1, here's your missing angle right here. We have a 62-degree angle and a 90-degree angle. And if you add those two together and subtract that from 180 degrees, then you get that angle 1 is equal to 28 degrees. So I added 62 and 90, 152, and then I subtracted 180 and 152 and ended up with 28 degrees. Angle 1. So angle 1, you'll notice that you have two angles that are missing, but you do have another piece of information that's marked, so you always have to look for additional information that you already know, either because of how it's marked or because of other relationships that you know, like linear pairs and vertical angles. Well, we know that those two angles are congruent because of how they're marked. Congruent means that they are the same size, so angle R is also 30 degrees. Well, if those three angles add to 180, and I have used 30 degrees and 30 degrees, I've used a total of 60 degrees, then 180 minus 60 degrees is 120 degrees. So for number 3 has this little right angle right here in the corner, and so you need to recall then that that means that this is 90 degrees. If that's 90 degrees, so is this one. And so you can use that then to find angle 1. So if you find angle 1, then I use this little triangle right here. If I use this little triangle, then I can find out that angle 1 is 180 minus the 60 and the 90, which is 150. So angle 1 has to be 30 degrees. Now, once I know that that's 30 degrees, I have two choices. I can use this big triangle here, and angle V is 60 degrees. This whole angle here at T is 60 degrees, also 30 plus 30, which means that then angle 2 has to also be 60 degrees. You can also see it by using this other smaller triangle, this one right here, that this 90-degree angle right here plus that 30 is 120, and 180 minus 120 means that this angle is also 60 degrees. So there are several ways that you can use it when you have multiple triangles in the picture. Then this one is going to force us to go back to information that we know. Don't forget, throughout this whole unit, we're going to need vertical angles and linear pairs. Remember that vertical angles are angles that are formed by opposite rays that share a vertex. And what we know is that vertical angles are always congruent. And that's going to be important. And so why that's important is because I know then that because of the way this picture is drawn, that angle 1 and angle 2 are vertical angles. That means they're equal to each other. So I can use this triangle right here to find out how big angle 1 is. And sometimes you just have to look at the picture and you have to start figuring out which ones you can use. So if I add 66 and 58 and subtract that from 180, then I know that angle 1 is 56 degrees. And I like to go in and mark it on my picture so that I have it. I don't have to keep thinking about it. Well, if angle 1 is 56 degrees, then angle 2 is also 56 degrees. And I need angle 2 because I have to find angle 3. So angle 2 is 56 degrees, so then you can add 56 degrees and 50 degrees, add those up and subtract it from 180, and you can find out that angle 3 is 74 degrees. So the fact that angles of a triangle add up to 180 is extremely important. We'll use that a lot along with linear pairs and vertical angles. Now, the new information that you might not know is the exterior angle theorem. So first, let me explain what an exterior angle is. Angle 1 right here is an exterior angle. Angle on this inside right here, this angle right here is an interior angle. So an interior angle plus an exterior angle form a linear pair, which means that they add up to 180 degrees. So this blue interior angle, this green exterior angle, those two add up to 180 degrees, which is why this theorem works. The measure of the exterior angle, angle 1, is equal to the sum of the two non-adjacent, you can also say remote, interior angles. The exterior angle is equal to the sum of the remote interior angles. What that means is that angle A plus angle B equals that angle 1. The exterior angle, angle 1, is equal to the non-adjacent. So A and B are not adjacent to that angle that is there with angle 1. Non-adjacent, remember, adjacent means side by side. So these angles are adjacent angles, these two angles, but this angle here and this angle here, those are non-adjacent. Non-adjacent means they're not side by side. They don't share a vertex. So if we use that, we can use that to find this. So we've got an exterior angle of 145. We've also got this A is 95 degrees and B is 2x. So if we use the exterior angle theorem, then we know that the sum of the two remote or non-adjacent interior angles is equal to the exterior angle. This is not the only way to work this problem, so I'll show you that in just a second. So if I take this then, I set it up to x plus 95. The sum of these two angles equals this outside angle. Then you can solve it. So you subtract 95 from both sides. You get that 2x is equal to 50, which means that x is 25, which is what I asked for. Now, there is another way to do this problem. If we go back to what we know, say you're sitting there and you're looking at the problem and you cannot remember what that theorem, that exterior angle theorem was. Well, if that angle is 145 degrees, then the interior angle of that triangle is 35 degrees. So I know that that angle is 35. What I do remember is that the angles of a triangle add up to 180. That means that 2x plus 95 plus 35 has to equal 180. So of the 180 degrees, I have used 35 and 95, which leaves me with 50. So 2x is equal to 50, or x is equal to 25. So you can use the sum of the angles of a triangle are 180, or the sum of the non-adjacent angles, the interior non-adjacent angles equals the exterior angle. Either one works. Now, where you run into a problem is a problem like number 6 that's all algebra. You can do this, and you can say that this is 180 minus 5x plus 6. So this could be done. You could call this one interior angle, and then you could use the sum of the interior angles as 180. But you can see how that could be a mess, mainly because of this minus sign right here. That's where you'll make the mistakes. So in this particular case, it is easier to use the exterior angles theorem, where the non-adjacent interior angles added together equal this exterior angle. So 5x plus 6 equals x plus 2x plus 20. So 5x plus 6, we need to simplify this. Now we're done with the geometry, we just need to do the algebra. 3x plus 20. I have a variable on both sides, so I need to get them on the same side. Subtract 3x from both sides and get 2x plus 6 equals 20. Subtract 6 from both sides and get 2x is 14. Divide by 2 on both sides and you get x is equal to 7. Now, with this next, 7 through 12, you really have a lot of different options. So I highly recommend that you pause the video for a second, go through, work it out using everything that you know. Don't forget, you know linear pairs, you know vertical angles, You know triangles, the angles of a triangle equal 180, and now you know that the exterior equals the remote interior. So you know all of those things, and so you can use any of those things to do this problem. So for instance, if you look at number 1, I know that number 1 is exterior, angle number 1 is exterior, and 68 and 36 are my non-adjacent or remote interior angles. So angle 1 is equal to 68 plus 36. But say I forgot that. Well, there are other ways around that. So I have 68 plus 36 is 104. So if I take that 104 and subtract 180, I get 76. So I can find this angle first if I needed to, and then I know 180 minus 76 is 104. That's why the exterior angle theorem works. So that's one thing that you can do. Now you need to kind of work your way around it. So what I do is I consider these kind of like a puzzle, and I just work everything on the triangle, and then I go back and I fill in the blanks. So I know I need to get over there to angles 2 and 3. So we have this 36-degree angle and 36-degree angle. Those are vertical angles. So these two angles are vertical, and vertical angles are equal to each other. Now, I don't have quite enough information yet to get 2 and 3. And you need to understand, 70, this angle right here, is not a vertical angle, because it is not a linear pair with angle 3, and it's not a linear pair with angle 4. So it is not a vertical angle on its own. Or excuse me, it's not an exterior angle. So you can't use the exterior angle theorem. So we need to keep working our way around. So I'm just going to keep going and find other pieces that I know. So I know that 65 plus 82 subtracted from 180 means that this angle right here is 33. If that angle is 33, then the angle that is the linear pair to it, which is angle 6, is 147. So that 147, and also you could also find that, again, here are your two remote exterior or your remote interior angles that go with that exterior angle. So that's another thing you could do, but you saw I used the sum of the interior angles of the triangle to get there. So then I can find all of my little pieces. So if I take 180 minus 118 is 62. Sometimes you might have to find pieces that you don't know in order to find pieces that you do know. Now, I still need to find angle 4, I need to find angle 5, and I need to find angle 2 and 3. So one thing I can do is look at this right here. Notice that these three angles form that straight line, which is a straight angle. So that means if I add 70 and 65, I get 135. If I subtract that from 180, I know that angle 4 is 45. Now I can find angle 5. 45 plus 62, and subtract that from 180 is 73. So angle 5 is 73. So now I still need angles 2 and 3. Notice I didn't find them in order, and that's okay. But again, if I go back to this right here, there's those three angles form that straight angle. So if I add 70 and 45, subtract that from 180, I find out that angle 3 is 65. If angle 3 is 65, then the 65-degree angle plus the 36-degree angle subtracted from 180 means that angle 2 is 79. And so you just work your way through the picture to figure out how big each of the angles are. So when you go through that, you can use linear pairs, you can use vertical angles, you can use any number of ways to find the measures of these angles. So sometimes you'll use those different things, and it kind of depends on the order that you see them in. So, and again, sometimes you may have to find things that you weren't asked for to find other pieces that you do need. So let's look at this last question. A triangle has interior angles. So as soon as you see that, you got to be thinking, okay, the interior angles of a triangle add to 180. Now, the first thing I notice is that I'm talking about a triangle, and I don't even have a triangle in the picture. I don't have a picture of one. So I'm just going to draw one because it helps me to frame out how I'm going to work this problem. Has an extended ratio of 1 to 2 to 3. So that means the three side lengths, or the three angles actually, because I'm talking about angles, the interior angles are going to be in a ratio of 1 to 2, 2 to 3, 1 to 3, and so on. So the easiest way to do this is to be in ratio to each other means that they're being multiplied by the same thing. So that means 1x to 2x to 3x. They all have the same multiplier. Well, that means this angle, I can just label it x, 2x, and 3x. That's why now I have this picture drawn, it makes it very easy for me to see what I need to do. I know that the angles of a triangle equal 180 degrees. So I can take x plus 2 times the x plus 3 times that angle and set that equal to 180. So if those three angles are 180, then 6x is equal to 180. And that means that x is 30. Now, x stood for something. X stood for this angle right here. So that angle right here is 30 degrees. If that angle is 30 degrees, then this angle is 2 times 30 degrees, which is 60 degrees. And this angle 3x is equal to 3 times 30 degrees, which is 90 degrees. Now, it's okay that my triangle doesn't look like a right triangle. I just drew it so that I could keep it straight and help me to know how to set this up, because as soon as I saw that I had those three interior angles, I knew to set it equal to 180, which is the interior angle theorem that we studied earlier. So it always comes back to that. So you can right now use these pieces: linear pairs, vertical angles. The interior angles of a triangle add to 180. And the exterior angle, a single exterior angle of a triangle, is equal to the sum of